This lecture will cover the second part of Chapter 8 for first year chemistry. We're on the slide that deals with balancing chemical equations. And again, as a reminder, this chapter is broken up into 3 quizzes. Quiz number 1 covers lecture number 1, quiz number 2 will cover lecture number 2, and quiz number 3 covers the types of chemical reactions, and that'll be in lecture number 3. So we're going to cover how to balance a chemical equation. First of all, a lot of students ask, why do you have to balance a chemical equation? Well, we have to obey the law of conservation of mass, or the law of conservation of matter. It goes by 2 different names. And it states that matter is neither created nor destroyed in chemical reactions. So when you run a chemical reaction, the atoms can either join together, or they can separate from each other, or you can rearrange them, but the number and type of each atom has to stay the same on the left side of the yield sign and on the right side. So you can't have a new element showing up, and you can't have atoms disappearing. So you have to keep the same number of atoms of each type on the left and right side of an equation. So how do you balance a chemical equation? Very simple. You put a coefficient in front of the substances that are involved to get the same number of atoms on both sides of the equation. And whenever you put a number in front, this coefficient, it's going to multiply the number of atoms in the formula by that number. Now the rules for balancing chemical equations are very simple. First of all, you just need to put the coefficient in the front. So we do some practice problems. I put the number 2 in front of the formula for ammonium phosphate. And so originally there were 3 nitrogens, now we've doubled it to 6 nitrogens. And originally there were 12 hydrogens, and now it's been doubled with the coefficient in front to 24. And the phosphoruses have been doubled to 2, and the oxygens have been doubled to 8. In the next example, I have 4 potassium acetate molecules, or compounds, and so what that's going to do is multiply the K times 4, the C times 4, the H times 4, and the O times 4. In the last example, we have 3 calcium nitrates, so that's 3 calciums, and originally we had 2 nitrogens, but we're going to triple it to get to 6, and originally we had 6 oxygens, so we triple it to 18. So if you put a number in front, that's going to multiply by all the number of atoms in the compound. Just as a reminder, the coefficient is the big number in front, and we call the little dinky numbers a subscript. On the next slide, I cover more rules, but again, we're basically reminding the students on these slides that you need to put the number in front. It's illegal to change a subscript, so if you're trying to balance the formula H2 plus O2 yields H2O, you cannot change the formula for H2O into H2O2. That is illegal. So don't do it. If you want to balance it, you put the number 2 in front of the molecule. So that will double the oxygens, but that also doubles the hydrogens. So if you're doubling the H's on the right side of the equation, you need to go back and double the H's on the left side of the equation. So now it's correctly balanced. You cannot put a coefficient in the middle of a formula. So if you're trying to make 2 nitrogens, don't squeeze it in the middle between the aluminum and the nitrogen. That is illegal. You need to put it in the front. So again, you put the 2 in the front. And again, if you double the aluminums on the right side, you have to double the aluminums on the left side. Rule number 4 states that you have to reduce the coefficients to the simplest whole number ratio. The formula 4 hydrogens plus 2 oxygens yields 4 waters is actually balanced correctly, but you can reduce it to the correct ratio of 2 to 1 to 2. Now you don't have to show ones, but I do on these slides just for clarification for the students. Now rule number 5 says you have to get rid of fractions. Coefficients have to be whole numbers, so you can't have a fraction of a molecule or fraction of an atom. So if you look at this example, we have a 1 to a half to a 1 ratio, and again, this is correctly balanced in terms of counting the number of atoms, but our rule says that chemical equations need whole numbers in front. So in order to get rid of this fraction of 1/2, you can double everybody to get to the correct ratio of 2 to 1 to 2. As we knew from all of our previous examples. And here's just a visualization of what's happening for the reaction of hydrogen reacting with oxygen to make water. So basically the hydrogens separate, the oxygens separate, and then the hydrogens bond to the oxygens. So we have atoms separating and we have atoms joining together. They're being rearranged into different format. And again, as a reminder, the reactants are on the left, the products are on the right, and the big numbers in front are called coefficients. Now, for the next slide, I cover some helpful hints to balancing equations that I've kind of learned over the years of teaching. So I've kind of hit some of the common problems that students have when they balance equations. So hopefully these helpful hints will help the students balance them easier. So Rule A says that balance elements that appear in more than one compound last. So for example, in this equation, hydrogen appears in 3 locations. Oxygen appears in 3 locations. So we want to save those elements for last. So let's deal with balancing the nitrogens because it's only in 1 location on the left and 1 location on the right. So you have 2 nitrogens on the left side because the N is in parentheses with the little subscript 2 on the outside. So there's 2 nitrogens on the left, but there's only 1 nitrogen on the right. So it's very easy to balance it with putting the coefficient 2 in front of the NH3 molecule. Now you can look at what other elements you need to balance. So if you count the number of hydrogens, there's 4 times 2 on the left, which is 8. And then, hey, look at that. There's 2 times 3 in the NH3 molecule. And then there's another 2 way at the end in the water molecule. So you have 6 plus 2, which is 8. So that balances out. And the carbons are 1 and 1, and the oxygens are 3 and 3. The oxygens were always balanced, so we don't have to do anything more. And if you want to, you can put 1s in front just for clarification, since there's a blank and a lot of students want to put 1s, but it's unnecessary. For helpful hint letter B, it says balance ion chunks as though they were one item as long as the ion stays together as a group on each side of the yields arrow. So in this example, I'm looking at the SO4 group. That's the sulfate group. There's 1 sulfate on the left side, but then there's 3 sulfates on the right side. So I'm going to balance the sulfate groups just by putting the coefficient 3 in front. Now that screws up the number of coppers that are on the left and the right, but I can fix that. And the aluminums, I can clearly see that there's 2 aluminums because of this coefficient of 2 in front of the aluminum molecule, or in front of the, or as a subscript on the aluminum, I'm sorry. And then you can just put a 2 in front of the aluminum on the left side, and then again we need to balance the coppers, which you've tripled on the left, so you have to triple them on the right. So sometimes it's easier to balance an ion chunk, a polyatomic ion, just as one group, as long as it stays together on the left and the right. Now for letter C's helpful hint, it's kind of a silly rule, but it says if you can't seem to get it balanced, start over and begin with a different element next time. So if you made a mistake, let's say for example A, and you tried to balance the hydrogens first, and you got them to balance, but then something happened, it kind of screwed it up or something like that, you can always just erase all your coefficients and start over. Just pick a different element. Another thing to do is sometimes it truly helps to just throw a 2 somewhere. So in this example for letter C, it's a very difficult equation to balance because the only element that's not balanced is hydrogen, and it appears in 3 locations. So it's not going to just take 1 number to balance it. You're going to have to put down at least 2 numbers to balance the hydrogens. So I tell the students, if you run into a situation like that where it's going to take more than 1 number to balance the chemical equation, why don't you just throw a 2 somewhere? And I tell the students, just put a 2 in front of the lithium. Now if you put a 2 in front of the lithium on the left, you're going to have to put a 2 in front of the lithium on the right. And then it makes the hydrogens and oxygens a lot easier to balance. Now I'm going to save hydrogens for last, so let's just focus on the number of oxygens. There's only 1 on the left and there's 2 O's on the right because you just doubled them with the 2 in front of the LiOH compound. So you're going to have to double the oxygens on the left. And when you do that, it ends up making 4 H's on the left, which balances the 4 H's on the right. Now this reaction is lithium plus water turns into lithium hydroxide plus hydrogen gas. And this reaction is a very common reaction. It's a group 1 element thrown into water, and it explodes and blows up in your face. So this was shown in a video earlier in the year where a guy throws chunks of sodium into water and it explodes. So this is an alkali metal reacting with water, and I nicknamed this the Beethoven reaction because the coefficients are 2, 2, 2, 1, which is kind of silly, but anyway, it works. Now for letter D, this is what I'll constantly be telling the students to do if they're stuck and they need my help. I always tell them, pick an element to balance, then I ask them how many are on the left side, and then I ask them how many are on the right side, and then I just scream at them, fix it. So for example, down below, I say pick an element, and most of them just pick iron because it's in 1 location on the left and right. So I ask them how many are on the left, and they yell 1, and how many are on the right? There's 2 of them, so fix it. Well, you'll need a 2 in front. And then I say pick another element, and they'll scream oxygen, and I'll say, why are you doing oxygen? It's all over the place. Save that one for last. So they'll say fine, hydrogen, and then I'll ask them how many are on the left, and there's 6, and how many are on the right? There's only 2. So how do you make 2 hydrogens turn into 6 hydrogens? You triple it. So you put a 3 in the front, and then it turns out that the oxygen balances perfectly with 6 and 6. And then you can put a 1 in the blank if you want, but it's unnecessary. So I'll just constantly be giving them the same prompts. Pick an element, how many are on the left, how many are on the right, and then I just tell them to fix it. And usually 1 number will fix it. Now in the next slide, we have letter E. It's a goofy balancing song that I had the students use. And this is a situation where you'll have 2 elements it's only in one, or you'll have one element, but it's only in one location on the left and one location on the right, but a single number doesn't balance it. So here's my goofy balancing song. If there is a 2 on the left and a 3 on the right, you put a 3 on the left and the 2 on the right and make money. Now, for some stupid reason, one year I just added the making money in there and the students laughed, so I kept it. Anyway, down below you look at the example. We have 2 oxygens on the left and 3 oxygens on the right side. So what do? You sing your song. There's a 2 on the left and a 3 on the right. You put a 3 on the left and a 2 on the right, and it's balanced. Now, it turns out that screws up the aluminum. Well, aluminum wasn't balanced to start with. But anyway, you need to have 4 aluminums on the left side, so you need to add another coefficient of 4. Now for the last helpful hint, and this will be the last slide for this lecture because we're only doing balancing equations, the last example uses carbon, hydrogen, and oxygen reactions. These are combustion reactions, and you always balance the elements in the correct order, the easiest order, which is C, then H, then O. So here we go. You pick an element and it's carbon. There's 2 on the left and 1 on the right, so you fix it with the 2 in the front. If you look at how many hydrogens there are, it's already balanced at 2 and 2. Now the number of oxygens on the right side, since they appear in 2 locations, you have to be careful what you're counting. So there's 4 oxygens in the CO2. There's only 1 oxygen in the water molecule. So that makes a grand total of 5. Now it turns out you cannot put a whole number in front of this oxygen molecule on the left side to get it to equal to 5, but you could use a fraction. So I'm going to use a fraction temporarily, and it's 5/2, also known as 2 1/2, because when you multiply 2 1/2 by 2, that gets you up to 5. So this equation is actually balanced, but it's illegal to use a fraction as your final answer. So what I'm going to do is I'm going to get rid of the fraction by doubling everybody. So if I'm going to double the oxygen to get rid of the fraction, I got to double the C2H2, I got to double the carbon dioxide, and I have to double the water. So my final answer is actually going to be a ratio of 2 to 5 to 4 to 2. And that's how you balance C, H, and O reactions, and that's also showing the students a technique of using a fraction temporarily to make balancing a little easier. So that's basically the second lecture for quiz number 2.